Hi, I am Satyanarayanan. Welcome to our channel. Let's impart knowledge and education. You can reach us through senddoubts@gmail.com. To see more videos, subscribe our channel and don't forget to press the notification button.
Problem number 5. In the beginning of compression stroke of a two-cylinder IC engine, the air is at a pressure of 101.325 kilopascal. Compression reduced the volume by 1/5 of its original volume, and the law of compression follows PV power 1.2 is equal to constant. If bore and stroke of each cylinder is 0.15 meter and 0.25 meter respectively, determine the power absorbed in kilowatt by compression stroke when the engine speed is such that each cylinder undergoes 500 compressions per minute. Listen, in the beginning of compression stroke of a two-cylinder, number of cylinders are 2. So, K should be written as 2. K is nothing but number of cylinders. At a pressure of 101.325 kilopascal. So, initial pressure is 101.325 kilopascal. P1 is equal to 101.325 kilopascal. Compression reduced the volume by 1/5 of its original volume. Listen. So, final volume V2 is equal to 1/5 of its original volume. So, V2 is equal to 1/5 V1. PV power N is equal to constant, that is small n is equal to 1.2. If bore and stroke, bore means diameter of a cylinder, inner diameter of a cylinder. Stroke means length between top dead center and bottom dead center, that is length of the cylinder. Diameter is given as 0.15 meter. Stroke length L is given as 0.25 meter. L is equal to 0.25 meter. Stroke is nothing but length of the piston. Determine the power absorbed in kilowatt. Power is asked. When the engine speed is such that it undergoes 500 compressions per minute. This is very important. Listen. Number of cycles is equal to 500 compressions per minute. So, for a cycle, if it is a 4-stroke engine, we have 4 strokes: suction, compression, power and exhaust. So, in a cycle, you will be getting 1 suction, 1 compression, 1 power and 1 exhaust. So, you will be getting only one stroke per a cycle. So, 500 compression means 500 cycles per minute. So, 500 cycles per minute. It is given in minute. So, you have to convert this into second. The reason is it is asked in kilowatt. Watt means joule per second. So, it should be in second. So, minute is converted into second. So, 500 divided by 60 cycles per second. You have to calculate power. We will solve the problem now. First, we will calculate volume 1, V1. The cylinder volume is pi by 4 d square L. You know very well, the volume of a cylinder is pi by 4 d square L. So, diameter is given, length is given, so that you can calculate V1. It is also given that V2 is equal to 1 by 5 of initial volume. It is given in the problem. So, V2 is equal to 1 by 5 into V1. From this, you can calculate V2. Since it is a polytropic process, you know the expression PV power N is equal to constant. So, P1 V1 power N is equal to P2 V2 power N. So, for all polytropic process, you can write this expression. So, from this, P1 is known, V1 is known, V2 is also known. From this, you can calculate P2. Listen. If you substitute all the value, you will be getting P2 is equal to 699 kilopascal. You know the formula work done, P1 V1 minus P2 V2 divided by N minus 1. Now you have calculated P2 also. So if you substitute all the values, you will be getting work done is equal to minus 0.854 kilojoule per stroke. Listen carefully. Since it is a compression process, the value should be in minus. If it is in plus answer, you have committed mistake somewhere. So you have to see the minus symbol. Now we have calculated for a single stroke. Okay. Now you have to calculate power. So power is equal to, this is a formula you must note down, work done into number of cylinder into number of stroke, because work done is calculated for all the problems, work done is calculated for a single stroke. So when the piston is moved from one position to another position, we have calculated, that is state 1 to state 2. State 1 means, for example, piston is at bottom position. State 2 means top position. For a single movement, you have calculated work done. But power should be calculated throughout the process. So for a single stroke, you have calculated. So you have to determine for all the strokes, total number of strokes. So work done into number of strokes. This is for a single cylinder. 2 cylinders are given. So you have to multiply it by number of cylinders also. So work done we have calculated, number of cylinders 2, number of strokes 500 per second, 500 by 60. That is very important, because per second you have to calculate to determine power in kilowatt. So from this you will be getting power is equal to minus 14.23 kilowatt. We are supplying energy to the system, so minus symbol.